All right, so today we're going to do 9.5, which is solving for a triangle. So we've learned how to solve for missing sides and solve for missing angles. When we're solving for a triangle, we're solving for everything. So we want all the sides and all the angles. So you're looking for any missing sides and any missing angles. So when we do this, the very first thing we're going to do is just label what we have. Okay, so we've got angle B right there, that's 44.7 degrees. And then side B, right, straight across from angle B is 9. And we have, angle C. Okay, that's our right triangle. You're always going to have angle C. It's always going to be 90 degrees. Okay, so now we've got some missing stuff that we need to fill in. So the first one I notice is we're missing angle A, but we already have the two other angles. So you can, use your trig ratios to solve for the missing angle, or we can just remember that a triangle adds up to 180 degrees. So we're going to subtract our two angles and see how much is left in our triangle. Let's see, so if we type that in our calculator, we end up with 45.3. So that means angle A is going to be 45.3 degrees. All right, so if you already have two angles, just check what you need to get up to 180. Okay, now let's look at our sides. So there's lots of different ways that you can set this up. You can use whichever angle. We just found angle A to be 45.3. You can use angle B that you already have. It doesn't matter. You can choose what you want to do. So let's look at using the angle B that we already have. We've got 9. And then let's say we want to find side A over here. So, that's a weird A. Okay, side A. So that would be opposite over adjacent, which is tangent. So we need the tangent of angle B, which is our 44.7, equals the opposite, 9, over the adjacent, which is our A. Now, this is a totally valid way to do this. Again, sometimes some people might have trouble remembering what to do when we have the A in the denominator. So you can totally solve it this way. You'll get the same answer. But what I like to do is watch for something that will just give me my variable in the numerator. So if I do the tangent of angle A, so 45.3, that's going to be A over 9. And then I don't have to do as much when I'm solving. So you can pick whichever one you would like to do. Or if you want to start with a sine or cosine, try and find your hypotenuse, you choose. But this is the one I'm going to do. So we're going to multiply by 9. So we get 9 tangent of 45.3 equals A. Okay, and then let's put that in our calculator. So let's see, we've got 9 times the tangent of, let's see, what was it? 45.3. Can we get 9.09? And we'll just go out to 2 decimal places. Okay, so side A, 9.09. All right, now we need to find side C. Or if you've already found side C, you would need to find side A. So this way, again, you can go about it a couple different ways. One way is you can solve for another side using the same method, do a cosine or a sine, so you're looking at your hypotenuse. Or we can do Pythagorean theorem because we've got two sides. So if we've got two sides, we can go ahead and do Pythagorean theorem, and you can choose again which way you prefer to do it. Either way is correct. So I've got 9.09 squared plus 9 squared equals c squared. And then let's go type that in the calculator. 9.09 squared plus 9 squared gives me 163.63. Make sure you round that 2 up since we've got an 8 after it. So 163 point, let's see, what was it? 63. Okay, and then all we have to do is take our square root. And again, we'll just go do that in our calculator. And we get 12.79. Okay, and that is side C. Okay, and now we've got all of our sides and all of our angles. All right, let's look at number 2. So number 2 is the same. On this one, it doesn't give us the triangle. We're going to have to draw it. So let's draw a triangle. So our right angle, that's angle C, and then you can just pick angle A and B, doesn't matter. Okay, so we have angle C is 90 degrees. Side A is 12, so that's going to be across from angle A. We get 12. And side B, across from angle B, is 9. Okay, so let's fill in what we have. Side A is 12, B is 9, and C is 90 degrees. All right, so starting out, what I want to start with is my sides because I already have 2 of them. So that means I can do Pythagorean theorem. So we've got a squared plus b squared equals c squared. So 12 squared plus 9 squared equals c squared. Let's see, what do we get? 12 squared plus 9 squared gives us 225. Okay, and then you need to take the square root of 225. So square root 225, and we get 15. So that means side C is 15. All right, now we can go for our angles. So our angles, we only have one of them, so we're going to have to do some stuff from last section where we solved for a missing angle. So you can pick if you want to do A or B. I'm just going to pick A first. So the sides, let's see, we can label this side as well. So we've got all the sides. So you can pick sine, cosine, or tangent. So I'm just going to pick sine. So the sine of angle A is opposite 12 over hypotenuse 15. Okay, and then we need to do our inverse sine on both sides. Inverse sine. And then on our left side, our inverse and our sine cancel out. So we get A equals the inverse sine of 12 over 15. All right, and that we can go ahead and type in our calculator. So let's pull up our calculator. We have the inverse sine of, let's see, 12 divided by 15, 12 fifteenths. Enter. We get 53.13. 53.13. So angle A is 53.13 degrees. All right, now we have 2 angles. So either way, you can solve like we did this one for angle B, or we can remember that they add up to 180. And let's subtract our 2 angles and see what we have left. And if you do that, you end up with 36.87 for angle B. All right, so overall, check which one you have 2 of. If you have 2 sides, do Pythagorean theorem. If you have 2 angles, subtract from 180. And then you'll probably have to do one solve for a side or one solve for an angle. And then you can either do a second one or you can use our little trick of Pythagorean theorem or subtracting from 180. All right, and that is it for this unit.